Good morning. You heard that wonderful talk about Raiders of the Lost Ark. I'm one of the ones that built the Ark in the first place. I want to take you back to 46 years ago when NASA started selection from 90 proposals. They chose 7 PIs and experiments for all the LSEPs on the 6 missions. And I was lucky enough to be selected as one of the 7. But it was for a charged particle lunar environment experiment for electron and proton detectors associated with auroras. So in Los Angeles, when we were talking about this and they were talking about dust, I said, who's going to measure the dust? And nobody was going to measure the dust. And as risk management, I thought it made sense to, at least on Apollo 11, see if there was any effect from the jet exhaust of the lunar module when it took off, potentially splaying dust over the experiments. So on the way from LA to Houston, January the 12th, 1966, I invented this. This is a real size dust detector, and after a certain amount of discussion, there are now 4 of them on the moon. So my role in dust was really for risk management. Now one of the valid questions is, why bother now talking about the, can we squeeze that in a bit? Or is it? No. Why bother now with the old Apollo dust data? And the reason is because they're still the only direct data from the moon. The only in situ measurements. It's, my apologies for the slide, I don't quite know what's happened here. The astronauts complained bitterly about, they were pointed out the problems, didn't complain, ranging from Buzz Aldrin there on the left with Apollo 11, Harrison Schmitt on the right, and his well-known summary that dust is the #1 environmental problem on the moon. But there are only 2 Apollo experiments to measure dust in the entire $30 billion program. One of them was 4 of these. That's on the left. That's the Apollo 12 one. And the other one on the right was the thermal degradation samples from Manned Spacecraft Center. 2 plates of 12 samples, each of things like various white paints, Teflon and so on. On Apollo 14, Alan Shepard sprinkled or splashed dust on them. And he took one of the plates and he brushed it, and he found that the dust came off surprisingly easily. And the other one he tapped. And it's the tapped one that I regard as one of the most joyous photographs from Apollo. There were 2 papers written on this. One was mine in 1970 on the dust experiment of Apollo 11. The other was Tommy Gold in 1971 on the Apollo 14. They have never been referenced until I started referencing them 2 years ago. PhD research ain't what it used to be in my day. But let's quickly go through the dust detector. There are 7 discoveries to date. They're still proceeding. They're all documented in 1970. And the next one was 2009. And the latest is this Planetary Space Science Review published this month. I won't go into those anymore, but I do want to quickly go to this one, which I think is absolutely magnificent. This is one of the plates. You see the white numbers there. They're written in red for convenience. The white numbers were indented, just a serial number, about 1 millimetre deep. And when Alan splashed the dust on, those numbers filled up with dust. And then he tapped it. And when he tapped it, 5 jumped out. 3 jumped out, 7 a little bit. This 3 crumbled, but you can still, it's still got limbs. That is the only measurement to indicate coherence of dust on the moon. Now that's not an academic issue. You've heard a lot about levitated dust of isolated particles, but the particles love to cling together. So if they happen to cling together into a 5, you wouldn't be levitating a tiny little particle, you'd have to levitate with your electric fields that stuff wherever. Fairly important. But the realization came to me that there's one issue about that the entire Apollo 14 TDS experiment was carried out within the aura of the outgassing of the astronaut. And on Apollo 12, the cold cathode gauge of Frank Johnson, this is outgassing here, this is logarithmic there, these are each hour. There was a blip as the lunar module depressurized, but a big blip which saturated when the astronaut approached. So there is an aura of outgassing several meters surrounding the astronaut. So what Alan was doing was basically hosing down the dust particles as he was splashing them onto the plates. That's another issue that, to my knowledge, has not been discussed. This is the one I want to spend most time on, and that's LEAM, you're all familiar with that, the Lunar Ejector and Meteorites experiment. It had many problems, I won't go through those. Had 8 unexpected effects. It was designed to measure cosmic dust, but it did not, and that's a question mark. We don't really know that. There's a false claim that it was virtually identical to Pioneer 8, so this publication makes a list of 14 major differences for the history. The events were from single films, not telescopes. Again, that's uncertain. Counts hundreds of times expected. Pulse heights maximum, the opposite expected, and so on. So the interpretation to date has been based on a theoretical analysis of the electronics and laboratory tests of spare LEAM, and the conclusion has been, the conclusion has been that particles, highly charged particles with velocities less than 100 meters a second are responsible for the counts. Now, I'm not quite certain what we can... Okay, this will do. These are the raw data. Let's just have a look at those for a minute. This is a typical lunar day, 500 hours here. It was turned off for 200 hours a day because it overheated. You'll see these are the counts in 3-hour tranches. The black is the published data, and the reds are my numbers of counts there. And if you look at those, you'll see that there are multiple counts. 2 2s, then 1s, and a 3, and so on. A 3, 1s, and so on. Now, for rare events, it's very unusual to get double events. Right? That's simple statistics, if you like. If you looked at that, my immediate thought was this is not particles causing this. This is similar to electromagnetic interference, bursts of noise, particularly from opening of current loops. And in looking at the reports on LEAM, pre-flight, there are Bendix reports in which there was electromagnetic interference in 3 different tests on LEAM and LEAM alone. LEAM has got very sensitive amplifiers, so one can understand that. So I advance for discussion the hypothesis that the LEAM events are caused by switching of currents in the Apollo spacecraft, the payload, and they're very heavy currents. The paper gives the details. So then I tried to check what other features of data such as this are explained by the alternative hypothesis. Okay, so we've got the hypothesis of lunar dust and the hypothesis of noise bits. Let's just compare them. Detective work we don't have time for. All the details are in the paper, but let me just back up. The raw data occur in bursts, and the duration of a burst is less than 0.6 seconds. And then there were the Bendix pre-flight noise bursts. Let's have a look at the no, keep going on. Have a look at this one here. This premise that lunar dust is consistent with the data on 3 points. It's double or multiple counting of slow pulses. We've seen that. Incomplete tests, well, lab tests were incomplete, but they found they've deduced that the dust particles which are highly charged but velocities less than 100 meters a second could cause it. Long pulses consistent with that. And the theories about sunrise and sunset were higher peaks, and of course that was, you see there, higher peaks near sunrise, higher peaks near sunset. So the question is, what sort of switching would have occurred in the payload at sunrise and sunset? The answer is, of course, switching on and off the heaters. So it's a matter then of adding up all the clues, and due to the problems that I'm encountering here, I'll just have to, I apologise for that, just have to tell you that there are, for the lunar noise hypothesis, it's consistent with 3 features of the data. For the noise bits hypothesis, it's consistent with 7 features of the data. Let me give you an example. The rate was 5 times higher at sunrise than at sunset. Sunrise, you open the switches. You all know that when you open a switch, break a circuit, you get more electromagnetic interference than when you close it. It's that sort of relationship that you can build up 7 clues, 7 explanations of the features as caused by switching of circuitry. I would like to add, there's been some very useful discussions yesterday and since. I'd like to add that when you try to explain data with alternative hypotheses, it doesn't mean that necessarily you've exhausted the list of alternatives. The thermal effects at lunar sunrise and sunset are enormous on the moon. What it does mean is that you keep striving to explain the features of the data, and as a result now of the magnificent work on searching for old data, hopefully we'll be able to chase down more details of the data and keep chasing towards the cause. But yeah, I think that's a hopeful note to end on.
On that note, might we end and ask people to join you for lunch to talk more?
Thank you very much.
Thank you. Any questions?
I just want to make a short statement that Otto Berg, the principal investigator for the LEAM experiment, that very senior analysts who were involved in the LEAM experiment, and several others disagree with the fact that Dr. O'Brien is saying that LEAM only saw EMI.
I am sorry, Lynn, I'd never said that. Read the paper, for heaven's sake.
Anyway, this whole issue will be resolved shortly. As a result of the LSEP data recovery group, we found LEAM data that the principal investigator never realized had been kept. And we have about 6 or 8 months of LEAM data, which Michele Orani at University of Colorado and his group over the next year will be taking a good look at, and this whole issue will be resolved. This meeting next year will know exactly what the instrument was doing, having been looked at by a very competent group of scientists at the labs at University of Colorado.
Thank you for your comments. With that, we need to move on.